Let's talk about briefly the lab last week. So last week our main focus was WebSockets, right? And the lab kind of tried to reinforce those concepts. And again, if you didn't get to the lab last week because we were talking about groups, that's all right. Feel free to do it on your own time or get to it this week. But let's just review some of the concepts, right? So when it comes to action cable, right? Um, Rails incorporated an action cable so that we can include a WebSocket framework, right? Which is really useful because rather than having to pull and not constantly ask for updates, we can just get that information directly from the server, right? So the server keeps track of which clients are listening to it, and then they sends out those notifications. So we had some, terminology I want to just review. So we had connections, and the connection is the actual link between the server and the client, right? And so the connection represents the data being transferred between the two, whether it's the client submitting a request to the server or the server broadcasting out a message to the client, right? That actual data transfer happens over the connection. And the way that we use that connection is through a channel. So we don't have to deal with necessarily the connection, but we instead deal with channels. And then the channel for us goes ahead and creates that connection. So last week we had a messages channel, right? And we broke the messages channel out by different rooms. So we could subscribe to a topic of a specific room. We had on the server side, we had a channel, we had a messages channel, which would take in requests from the client and broadcast those messages back out to everyone else. We also had on the JavaScript side, right, an interface that let us send messages to the channel. And so we can create multiple channels. In the app last week, we had two channels. We had one for messages, and we had one for the list of users who were logged into the app. So we had a kind of a sense of who was logged in, who wasn't, and that was one channel. And then a separate channel was the messages coming through each room. There's also subscriptions, so that lets us kind of break it out into different topics. You can have a subscription per each room. And finally, on the client side, right, which we implemented as well, we can subscribe. A lot of the kind of configurations handled for us by Action Cable, which is really handy. But on the client side, you can see. Here's more server side. Here we go. Right, this kind of look like our client side. So we have a file. Right, we messages.js. Actually, let me just pull it up here. Right, so we had here our client to handle the data. So here it will let us create a message. We could send the message to the server, and then the messages channel, right, would receive that message and create it and send it out to everyone. We also had a function to receive data. When we received data, what happened? Well, we received two types of data. The first was just a new message being sent out. And so we said, all right, if the data contains a message, go ahead and add that to the div, to the messages div, right? So find the UI, find the appropriate div in the view, and go ahead and add in some HTML, right? The other thing we did was deleting messages. And so if the data that came back to us from the server contained a deleted ID field, we assumed that meant that the data was meant to be deleted. And so we went ahead and found the relevant portion of the UI using some jQuery here, and then we simply just removed it from the view, right? So that let us both receive data from the server, handle it on the client by showing it. It also let us receive a deleted ID from the server, and then go ahead and delete that message. So this is kind of how we handled the action cable side on the JavaScript side rather than client of sending messages, receiving messages. And then our channel, right, very similar. Notice this time that we are no longer using the messages controller, right? So the messages controller still exists. It still has the create functionality and an index, right? And we use the index when we first log in. We show the page. We hit the index action. The create action still exists, but we decided to bypass it and go with everything through the channel. And that is when you're using WebSockets, you want to be careful because that connection is maintained for the length of the time. It's like one connection. It starts to make more sense to pass things through that connection rather than having separate requests and then also then trying to use the channel. So in this case, right, we sent the request and we wouldn't actually show it on the client side until it got broadcasted out, right? So if we added in a message and press send, there was a slight delay because the message would send to the server would save it, and then it would broadcast it back. When it got broadcasted back, then we showed it on the client. Um, and that's a little different, right? On a controller, if you have a create action, you typically want to also return that immediately. And it's usually an inline operation. So in the entire course of that operation, you're creating a message, you're saving it, and you're returning it. Right? It's a little different operation, right? The one we didn't return it. It just sent out a message through action cable. Whereas the controller, typically you want to, a typical RESTful API is when you create an object, you also then return it. So having this around can be useful because, for example, let's say we have like an administrator page, right, an admin page. We want the admin to have certain functionality, right? Maybe then we go through the RESTful routes. Maybe then the admin can create a message this way and immediately see it. But we wanted to, for all of our users, right, use the action cable way, which is going through the channel. So we created the message, we saved it, we had some HTML. I remember we used partials, so that was this magic down here where we got access to the actual partial. So messages underscore message is our partial, and this is what it looks like. It just it displays the username and the message, and typically the partial gets inserted into the view when we return HTML, right? So if we use a controller, right, we have here HTML, and we have code that gets formatted, and that oftentimes includes the partial. But this time we wanted to just return the partial as HTML with all of the relevant fields filled out. So here, right, we have message.body. We actually wanted to go ahead and turn this ERB file into an HTML file, which means fill in all the relevant data. So replace all of these placeholders with data, right? And so we can do that here with the partial. Right, we're asking us basically to return the HTML, and here we pass in the object. So we use the keyword locals, and we have a message object, right? Because that's how we define it here. We have a message object. So we say message, and then we ask for the actual object, pass it in, and that returns to us the HTML. And then from that HTML, we can pass that to the client, which we did up here, right? So we pass that down to the client in the data hash, and then the client will go ahead and display that and add that to the view. Okay, so that hopefully got a little bit of familiarity with how action cable works with channels, with subscriptions, with different types of responses, right? So here we also added in a second type of response just to return some data. This would just be like a string, right? What data was created. But you kind of start to see how you can use this in applications, how it can start to work with different workflows, right? So hopefully it starts to make sense, and feel free to use this in your project if it makes sense for the use case that you're using. If it doesn't, don't worry about it. But definitely kind of a nice thing that they added in Rails. No longer have to just rely exclusively on polling. So that was WebSockets. One thing I wanted to cover this week is this cool thing called exercism. And actually, so we have no more homework, which is great, but there is an optional, you may see here, interview prep tab. For anyone who's curious, there is some optional questions. Is anyone looking to try to get a job after this with Ruby on Rails? Great. Okay. So a lot of people. So the project is definitely helpful because the project is great to showcase off at demo day. And also when people go to an interview, a lot of times they'll ask you, explain to me a project you worked on. And they may ask you technical questions. They may ask you to kind of drill down into architecture. So it's definitely good to develop the project. But they also might ask you an algorithm question. So we can also do a little bit of work maybe to practice algorithms. So here is something if you want to, at your own leisure, and if you want to even submit it, we can get the TAs to grade this and give you some feedback. But it basically is a chance just to work on data structures and maybe kind of think about how to solve some questions you may get in an interview. So here's a list. It's not very comprehensive. I think there's one in week 4. Okay, there's none. So this is the first week we have it. There's some. Or sorry, last week was week 5 rather. That had some. This week has some more. So just kind of topics to cover. Big O is important. Who here knows Big O notation? Okay, so a few people. It's basically a way to categorize runtimes, and it's very often used as kind of a nice way to summarize the performance of an algorithm. So if you're not familiar with it, here are some links. Go ahead and feel free to read them, check it out. Ask me questions later if you have questions about it. I'm happy to go drill down and do it further. So this is some useful things to review. So if you're not familiar with Big O notation, I'd recommend check this out. As well as if you're not familiar with how hash tables or hash maps work, or dictionaries, different terms for the same thing. Feel free to read them. In Ruby, we use a lot of hashes, so definitely useful to understand how they work, understand how they're implemented, and understand how to use them. All very important things. But this is mainly reading, so I'd encourage you, at your own leisure to read these. But sometimes it can be hard to motivate ourselves to read it. So to motivate ourselves to do maybe a little more work with algorithms, there's this cool tool called exercism. Um, has anyone used this? Has anyone heard of it before? I actually hadn't heard of it until recently. But we can join a team, and I created a team for us, Coder School. And I think the way you join a team is you have to create an account, and then if you look at the bottom, there's a Teams link, and navigate to the team search page. And if you search for it, it'll show up, and this is the team. So basically, what's really neat is we can all join the same team, and then we can do some exercises, and we can see how each other implement certain things. You can provide feedback, and the way with exercism is you can they have different exercises to complete, and each one's not terribly long. You can complete an exercise, and I did a few actually this afternoon. So example, hello world, the most basic one, right? There's a README, and it's heavily on test-driven development. So it'll basically submit a test, and you have to keep writing logic or code until your test passes. And so this one is very basic, and I can show this one to you. Oops. So this was hello world. So you basically just get a test, and the goal is to get the test to pass. And this one's very simple. As you'll see here, there's only one test, right? Assert equal that if you call this functionality, right, you call this class method, it'll return to you hello world. So what did I do? Right, very simple. I just implemented this, which is just a class. You call the function, it returns hello world. And you'll see, right, that makes sense. That's my code here. And you'll notice it's iterations. So it's a chance for people to provide feedback, provide reviews. Maybe you can improve upon it and say, oh, like, interesting approach. Maybe you could improve it by doing this, and you can then try again and it'll show up here as a different iteration. So you can kind of work through it and build upon it and improve your answers. This was the most basic one, right? Hello world. But it's kind of cool to start doing some exercises. We can provide feedback to one another, see who does what, and maybe learn from each other's coding style, and hopefully encourage you to try more and try to maybe do the most in the class or something. Maybe you'll have a special reward for whoever completes the most. So let's see. So let's check out all the Ruby exercises. There's a bunch. It's also just a handy tool for if you want to learn a new language. There's clearly a lot of different things to work on. We're curious mainly about the Ruby one. And as you see here, there's a whole bunch of exercises. But let's see if we can do different to squares. This one doesn't seem too complex. So there's a command line integration. It's pretty simple to install. I already installed it this afternoon, but I encourage you to all do it as well. So I'll go ahead and fetch it, different to squares. Great, so now we see it here, different to squares, fantastic. Oops. So I'm gonna go ahead and close these ones out. And then we'll open it up. Great, and you'll see here there's a README. Basically the goal is to find difference between the square of the sum and the sum of the squares. The way we'd run this is, here's a test, difference of squares test, right? So this is test-driven development. The test is outlined for us. We haven't done anything yet. So if we were to just run this test, we'll go into it. All right, we'd run Ruby, and then there's only one file to run, so difference of squares test. And you notice here it says, cannot load such file. File doesn't exist. Okay, so we can fix that. So we'll create a difference of squares.rb. We'll save it. And we notice here it calls squares. So we'll probably want to define a class that meets that, right? So we have our file now. You'll see here the file path is defined. So different to squares, great. We've defined our file. It's going to ask for class squares. So we'll define the class squares. Great. Now let's see if we run it. Oops. Wrong command. We'll run our test again. Now the test runs. A few things to note. There's a bunch of skips and there's an error. So right now only one test is actually running. You notice here all these are skipped. But the one test that's running failed. And there's actually, right, it'll say wrong number of arguments on initialize. And that makes sense because here it's going to call new with some number. So if we define new, right, Maybe we want some number. So maybe we're going to say self.num equals num. And we're going to take in that num. Actually, this should not be new, but this should be initialized. And we want to make this accessible to everyone. So we'll basically define a getter and setter for that, which lets us access it outside of it. So now if we run our test again, great. Different there. Undefined method square of sum. So if we look at it here, it's creating a new squares object, passing in a number. Great, we handle that. Self.num. But now it's asking for square of sum. So that means we have to define, right? Square of sum. So let's say we just find it. We'll keep it blank. Let's see what happens. Great. So now the test runs, and it's expecting the output of 1, but it's actually nil. That's because we return nothing. So what is it trying to do here? Passes in 1 and returns 1. So we could, of course, just say, return 1. And now our test pass. So now maybe we say, oh, we think we have a good approach. Let's see if it works. So we'll go ahead and delete the skip on the next one. And we'll run it again. And now we get 1 test pass and 1 test failed. And we get that because it says 2 assertions and 1 failure. So that implies that 1 test passed. Right? So now it's asking us for the square of sum 5. And it's expecting 225, but it actually returned 1. So now we know our logic is not great because we're returning 1. So we should start to think about what we could do. So we have square of sum. So if we have the number 5, right, that means that we're trying to square the sum. The sum of what? I think it's the sum of all the numbers that come before it. So maybe we'll have a sum, and we'll say like 1 to num. And maybe we'll turn that to an array. And actually, it's a range. We can just call it .sum directly. So maybe we'll just say, what if we return sum times sum, right? We'll take the numbers, we'll add them all up, and then we'll square it, essentially. So now let's go ahead and run our test again. And it looks like it passed. That's pretty good. Notice here, though, that we can probably already start to make improvements. So our test pass, that means logic is good, but we call the sum method twice. And what will the sum method do, right? Well, sum will go from 1 to m, or 1 to num, and it adds them all up, right, by calling sum. The other way we could do this, is .map or something, right? And we have some number, or actually we want to do .reduce. We have some number here, right? So we'd say like sum and x, and then sum, plus equals x, something like that. Sum equals sum plus x, right? Something like that. We can call sum directly, and essentially handles it for us. But we're calling this operation twice, and so it's repeating work, and so it's doing it twice. And so maybe rather than having to do it twice, we can save our result. Right, just like that. So we memoize the results. We only compute it once. We save it here as at sum. And that way, the second time it gets called, we don't have to repeat the calculation. We can just access it again. This one? So this one here is going to call our method sum right here. .sum is a method on an enumerable. So if you have an array or like a range, you can call .sum, and it will basically add all the elements together, assuming that they're all integers. Here, right, this isn't called on an object. It's just its own call to sum. So it's going to look for a method by itself. And that's what we have here.
Yeah, but I'm so on line 14, right? When we run .sum on a range, right?
Mm-hmm.
Is that calling the enumerable sum?
This is the built-in Ruby method on the enumerable. Great. So right, before we had this, right? Oops. Before we added in this part, the test still passed and the logic was still right, but we're just adding in some optimizations. And maybe you publish this code to exercism, someone gives you some feedback, and then you add on it and make it better. So great, our test passed. Now maybe we can comment out the next test, run it again, and we're feeling pretty confident, right? The tests are passing, great. We'll keep going, right? We do the next one, and what happens? Now we get an error. And this next test is now calling a different method. Before we were calling square of sums, which we just implemented. Now we're calling sum of squares. So we should probably implement that. So we'll define that here, right? We run our test. Now the test runs, and it says, oh, we had failure. We expected 1. Actual was nil. So what is it doing here? This time it's calling the sum of the squares. So that means that it probably squares things and then sums them all up. So if we have a number, right, sum of squares. So so yeah, so we take each number, right? We want to maybe map it, and we'll square it, right? So we'll call, say, x here, x times x, and then we'll sum that, right? So we take each number, compute its square, and then sum it. So let's see what happens. Great, our test passed. We'll start to get maybe confident. Maybe we'll comment out the next 2, and let's see what happens. And oh, our tests are passing. This is really good. And now it looks like we have a new method, difference. So if we were to uncomment out, remove the skip, the test would fail. So we should implement this function, difference, here. And it looks like it's asserting the difference between the 2. So something like sum of squares minus square of sum. I'm not quite sure which direction, right? I guess it's positive. So which one would we expect to be bigger? Well, if we don't want to think about the math, we can just cheat and look at the results here. So square of sum is 225 for 5, and sum of square is only 55. So we'd expect square of sum to be bigger, right? So that means I should probably invert this. And maybe we'll try our test, and it looks like it passed. So maybe we'll remove these guys, and looks like our test is pretty well. So far, so good. Oh, one more, and oh, look, looks pretty good. Now there's one last test, and that's, I guess, the bookkeeping, just to keep track of which version of the algorithm we're running. I think it looks like over time they modify things. So it looks like this one is version 4. So I want to make that version 4. And all of our tests pass. That's fantastic. So, right, we kind of use test-driven development to write out some functionality here. We maybe can make this better, right? But let's publish it and see if people give us feedback or responses. So I believe the way to publish it is with submit. Let's try this. Submit, and I want to submit difference of squares. Great, it's been submitted. And if we go back and maybe we check out the dashboard, there we go, difference of squares. So now we can see our code, right? On the team, people can start to give feedback. Maybe someone gives feedback, we can iterate on it and kind of come up with a second solution. But this is something cool, so let's try to utilize this next week or 2. Take a look. There's a bunch of different problems, 85 to be precise. So some of them take more time. Some of them are pretty straightforward. The one we just did was pretty straightforward. So some of multiples, right? This seems like a pretty straightforward math one. But some of them, score a bowling game. That seems pretty interesting. Some of these get pretty technical. So like given a DNA string, compute how many times something happens. But yeah, feel free to check it out. Cool. Any questions on exercism? No? Sweet. Alrighty. So let's keep going then with the stuff for this week. We're going to talk about exercism. We're going to talk about kind of using Heroku. Let's go ahead. Cool. So this was our app from last week. Same one. And I'm going to create a new branch. Lecture 6 live. Great. And we'll close out these. Right, so our same kind of messages app from last week, right? We had messages, we had channels, and if we want to push this to Heroku, right, we got to create a Heroku command, right? So now that we have it up and running, we have our app. We tested it locally. It looks pretty good. We added in WebSockets and use Action Cable. Let's push it to Heroku and start to play around with different Heroku commands and kind of familiar with kind of Heroku, right? So if we want to create a Heroku project, you can pass in a name, but I don't really care about the name, so I'm just going to call Heroku create here. And let's see, we got a funky name, Quiet Scrublands 0863. Right, and if we check out Git Remote, we'll see here. Actually, I'm going to do this. Right, Git Remote. It added in Heroku. Great, right? So now we have our origin, which is our Git repository, and we have Heroku, which represents our Heroku account. So the way to run, right, is git push. I'm going to push to where? I'm going to push to Heroku. Now Heroku uses Git to handle code deployment, but it only listens to the master branch, right? If I just do git push lecture 6 live, it'll push which branch? It'll push this branch, right? Lecture 6 live. What will happen? Heroku is just going to ignore it, right? Heroku doesn't care about anything besides the master branch, and it'll exist in the Heroku Git repository, but nothing actually comes of it. So it's very tricky because sometimes you can push a code and you won't actually see it reflect live on the app, and that's because you pushed a branch and you didn't push it to master. So we want to push, if we're pushing just the master branch, right, we can just say git push Heroku master, but we want to maybe push a different branch and try things out before we push it, merge it to master. So we're going to go ahead and say push this branch, but push it to the master branch on Heroku. So we send this command, and notice here the push was very quick. It compressed things, wrote it, and now Heroku does a bunch of stuff where it detects it's a Ruby app. So it'll use a Ruby version, and it goes ahead and runs this command, bundle install. And it notice here it runs without development, without test. A lot of times you notice in the gem file where we say group development, group test, right? So, right, in the gem file we have group development, group test. You also can define like a group production. So when you push to Heroku, it'll fetch gems without the development or test groups. So only the gems you need for production. Right here installs all the gems, pretty standard. It compiles our assets for us, and then some warnings like we don't have some things defined. That's all right. Done and launching. And here verify deploy, and you notice it pushed our branch to master. Great. So we could go to the Heroku UI and try to launch it, or we can just say Heroku open, and that'll launch for us our app. And something went wrong, right? Uh-oh, what went wrong? Well, right, we did do some things, but let's say we don't know what's going on, right? Looks like we have some ideas as to what's wrong, but let's say we have no idea what's going on, right? We say, oh, uh-oh, the app isn't working. Let's check it out. So we can say Heroku logs tail, and it'll go and give us a stream of the logs. And here we see great, right, initial release, starting it up, and uh-oh, relation rooms does not exist. Notice though that the database does exist, right? So we don't have to actually run Heroku run Rails DB create, right? This command, Heroku run Rails DB create, right? We don't need to do that because Heroku automatically does that for us. Heroku and Rails work really well together, and you'll notice here that we just created an app. Let me see if it launched. Let me refresh here. And here we go. We have Quiet Scrubland. And you notice that it already created for us a database, right? It already gave us the Postgres database at the hobby dev, which is like the free level, which is fantastic, right? So it's automatically created it for us, so we don't have to run Heroku Rails DB create, but we do have to run the migration. So we got to run Heroku run, which opens up, that basically runs commands on Heroku on our dyno. So we're going to run Rails DB migrate, and it'll spin up a dyno for us. Now, if we inspect the logs, actually, we notice here as well that even the one-off commands get run in the logs. So, right, here's our web dyno, which handles our web traffic. Here's some information about the router. Heroku handles routing for us, but it kind of gives us information at the network layer. And then here says Heroku run, and process exited with status 0. That's a success. Great, looks like our data, our database tables were migrated. So we'll try again. And great. Looks like we have our basic app, something we recognize. So we'll create maybe our Ruby app and add my name, create room. Let's see if it happens to send test message. Right? Uh-oh, didn't get sent. What happened? Well, let's inspect the logs. Here we go. Cannot execute command. You guys see this? Specified Redis for action cable, but the gem is not loaded, right? So, telling us to install the gem Redis. Why? Well, we use action cable, right? And if we look at cable.yaml, you notice here that in development and test, the adapter is async. So that means that our web layer can handle both the web requests and the action cable requests, right? Action cable uses the /cable route, right? Remember the /cable? So our web layer can handle that, and that's fine because it's only one web server, right? But what if you have multiple web servers? You have 5 web servers, so you have a lot of traffic, right? Well, you may have a lot of connections, you may have a lot of users who are currently connected to the web, and you need a way to kind of keep track of all these connections. Maybe one web server handles an incoming request, and another one sends out all the broadcast messages, right? And you want some way to keep track of which users have an open connection to the system. And so, as a result, in production, we use Redis, right? You notice here it says Redis. Who here is familiar with Redis? Anyone? Okay, so let's talk about Redis. So Redis is a data store, and it's very fast because it's entirely in memory. So because it's in memory, there's no disk. So a lot of times it's used like as a caching layer. It's also used when you have to really access things that are very fast. So WebSockets, right, happen very quickly. You don't want to really, have to hit the database every time to see what connections are open. So it's a good use case for Redis. It's a key value store, but also supports data structures. So you can put it as a value as a string. You can use like a set, and you can say add this item to the set, remove this item from the set. Sorted sets are very popular because you can allow it to have some sort of ordering to the set, but it still only allows one value, so it doesn't allow duplicates. It's a great utilization to use when you have something that you need to access very quickly. The downside is because it's so fast, it's a little more expensive, right? So data on disk is going to be cheaper than data on memory because in memory it just costs more. The other thing is it's not completely persistent. So let's say you have a Redis server, and for some reason the power goes out, and the server is now down, right? All that data is lost because it's stored in memory. It's not stored in disk. As a result, a lot of hosted Redis options will let you have a backup. I mean, at a fee, but you can pay and they can back up your data so that if things happen, you have a way to restore it. But for data that should be truly persistent, it's still a good idea to use Postgres. So a lot of times for data models and stuff, we still have our schema. We still use Postgres for that. But Redis is kind of a nice intermediary. And Action Cable uses it. So we have to use Redis for that. So if you want to use it locally, you have to install it. I already installed it locally via Brew. But if you want to install Redis, right, pretty simple. You just run some commands. Right, it'll kind of walk you through the process, how to install it. Pretty quick. You also can use Homebrew. But we have it here in our application. Let's go ahead and uncomment it out. Right, so we want to add Redis, and then we also want to run bundle. Make sure we have it. Great, so we ran bundle. Looks like we have Redis. A few things to know about Redis is it runs. So it runs as its own data store, right? So we kind of need to add it in Heroku. We need to make sure that we have a way to run Redis in Heroku. We also need to make sure we can run it locally. So the way to run it locally is redis.server, and here we go. It looks like we have an open connection now. Redis typically runs on this port, so anytime you'll see Redis, it's always going to run on this port 6379, and it's so common that even on Action Cable, you see here it already is configured to run on that port. Great. Redis is open source now, so the source code is out there, but there are many different options for hosted Redis. So basically, companies will basically configure a Redis cluster for you, a Redis server, and you don't have to worry about configuring it yourself and making it run and stuff, um, which is great. Redis, by the way, just as an aside, is kind of the natural successor to Memcached. This was one of the first kind of use cases for like a distributed in-memory store. Uh, Very fast, very in memory, but it was kind of the first iteration, and so it had some improvements, but there's some things that people realized they can improve upon, and so this was very popular until about 5 or 6 years ago when Redis became the latest and most popular thing. So now Redis is the most used. So we added in here Redis. Great. So let's go ahead. We ran bundle. We Redis over here. We ran bundle. Great. So now we'll go ahead and have to push to Heroku, and so we can get that gem on Heroku. So I'm going to go ahead and commit. Add Redis gem. And we say what? Git push Heroku. And we say, what is it? Lecture 6 live. Pushing to master. All right. While that's pushing, for those who are curious, Redis is pretty interesting. A lot of commands to play around with. So there's some tutorials. This is kind of a list of all the commands you can use. So obviously very much a lot. Let's see if we can search by like sets. So let's say you want to set in Redis. You can add things to sets. You can subtract things. Very powerful interface. If you're curious, there's some tutorials you can check out, play around with it. We also can play around with it locally if we wanted to here in the Redis server. But looks like great. So we went ahead and pushed it. Push is complete. And our logs show us, oops, our logs got stopped. We'll go ahead and restart them. And it looks like here we still have an issue. Error connecting to Redis on localhost, right? What does that mean? Well, we push Redis. Now it recognizes that it should use Redis. It has the gem, but it's going to connect to localhost. And that doesn't make sense. That only makes sense for us on our local machine, right? If we're on our local machine, this right here points to our local Redis server, right? But now we're no longer running it locally. We're running it through Heroku. And so Heroku localhost is going to look for Redis on the same dyno, like a Heroku server, right, as our web server. And that's problematic because Redis doesn't exist on our web server. We actually have to add it. And the way that we're going to add it is with Heroku add-ons. So we have our Heroku app. Say Heroku add-ons, right? What add-ons have we currently added in so far? And it looks like we've added in just one. Heroku Postgres, right? So this is our database. It tells us our plan, how much we're paying for it. It was created. Same thing here on the dashboard. Installed add-ons, you can see it here. So all these commands, you can do it through the web UI or you can do it through the command line. It's really up to you. So we're actually going to want to create Redis and use Redis as an add-on, right? So if we check out our config, we'll see here our different variables. We'll see here, so we have our Heroku add-on for Heroku Postgres SQL, and the way that it knows to connect to that is the database URL here. And you notice there's different parts of the URL that are important. So over here, this is the EC2 image that the database is hosted on. So it knows where to route it. Before the @ sign, you'll see some different things. This is our username. So this is our Heroku username, and this or our Postgres username, and this right here is actually our password. So if we have the Heroku right kind of application, sure. If we wanted to, we actually could even try to connect to this database, right, using username, password, and that is the kind of location of our database. So if we wanted to, we could connect, kind of inspect the database, which is interesting. So there's our database URL. We also have some other information here. So we have the Rails environment is production. Great. And here's our secret key base. Where does this come from? You'll notice here in secrets, right? For development and test, we store the secrets in the code base because that's fine. We're not too concerned about people stealing our secrets here. But in production, right, you don't want to store secrets on production in your code base. Why? Well, because one, a lot of times they're open with GitHub, right? Unless you pay for a private repository, it's an open database, people can see that. Two, even if it is private, you have your entire history saved. So someone who wants to could go back and look up the password maybe from last year before it got deleted, and they have access to it. So as a result, you don't want to store your secrets in Git. And so you notice here that it does some kind of fancy work. It calls the environment variable, and it asks for the secret keybase. This was something that Heroku and Rails worked on together over time. Rails became so popular in part because Heroku was a great way to host your Rails applications. And so they kind of had a lot to do with development over the years. A lot of the Heroku engineers have contributed to the Rails open source, and they have a nice relationship. And so Heroku said that we need a way to kind of get these variables and define them without having to put them in the code base. So the way we do that is through the environment variables. And you notice here that the secret key base, right, corresponds to the config. So if you run Heroku config, we'll see that the secret key base, right, is defined here. And so when Heroku launches its applications, it'll take all of these variables and it'll put it under the environment. And the way we can access it is simply by calling the environment with the variable. It's a hash, right?
Where is stored environment variable?
Where is environment variable stored? Right? It's only stored in the application. So the way to store it is Heroku config. So we can say Heroku config set, for example, right? I'm going to say, some key var equals test. And notice that anytime you set it, it actually restarts all of your apps so that they all have that variable. So now if we run Heroku config, right, we'll see here that the variable is set. Some key var is test. And if we want to remove it, we can say Heroku config unset. So config is essentially like a, I didn't say some key var. Great. So now let's go ahead and remove it. So config essentially it's just like a hash or key value store of some things. You can access it two ways. One is this way, right, with the command line. The other way you can access it is settings, I believe. And here you have the same things. So if you want to, you can play around with it here right? But essentially, these get loaded into the application. The application can then use them here. So, right, we have adapter Redis. The URL, right, shouldn't be that. What should the URL be? Well, we're going to need to add in something, right? And what is that something? Well, we actually haven't configured it yet, so let's go ahead and configure what we need to do. So we said we had Heroku add-ons, right? And the current one we only had was Postgres. So we want to add a Redis add-on, right, and configure a Redis database. So let's check out Heroku add-ons and see what we can get. So we'll navigate to the web page. Here there's a bunch. Let's see them. So there's all sorts of add-ons you can look for. We're curious about Redis. Let's see if I can search for it. It looks like here are some add-ons. We have Redis to go, Redis monitors, I think it's for monitoring. We have Redis Green, Redis Cloud. There's Heroku Redis. We'll back and we'll just look at it this way. So we have Redis Green, different providers of the same service, Redis, and they all have different tiers. So for example, if we look at Redis Green, and we say, how much would this cost us? Here's the plans and pricing. So the minimum size you can get is $14 a month with this provider, but you get 160 megabytes. It's quite a lot of data. It'll back it up for you every hour. So if things go down, you can always restore on an hourly basis. You have 512 connections, which is a lot. They allow you to even auto scale and provide some analysis. So that's kind of useful if you have maybe production level traffic with actual users. This seems like a pretty useful set. And as you start to grow, you can upgrade your plan. You can get bigger, and you have to get bigger and bigger plans for a different fee. That's useful. There's also one. There's Heroku Redis. So Heroku has its own hosted Redis service. As well, it's free, the basic plan, which is very useful. You only get 25 megabytes, which is not a lot, but it's free, so you can't really complain. and 20 connections. I personally prefer Redis Cloud. Um, they also have a free tier. We have a little more memory, a few more connections, and then a lot. If our app takes off and starts to get more successful and maybe grows out, we can start to scale it more and more. So the way to add it is tells you right here, Heroku add-ons create, right? Redis Cloud 30, and that's essentially going to give us the 30 megabyte tier, which is free. One thing to note is this plan is free, but Heroku does require you to input in a credit card in order to add in an add-on. So if you want to use any add-ons with your application, you have to have a credit card on the account. The credit card won't get charged yet. It won't get charged on this plan because it's free. But if you decide, for example, to upgrade plans, it'll then start to charge you. Just one thing to note. So we're going to go ahead and create this add-on. And it'll go ahead and create it for us. It actually does a lot of magic. So now if we do Heroku add-ons, we'll notice that we have two add-ons. We have our database, PostgreSQL, and we added in Redis Cloud as an add-on. We also, if we inspect the config, right, we'll notice that when we ran Heroku add-ons, it created some config variables for us. So it actually created for us here Redis Cloud URL, which is our URL. And it's actually smart enough to even hide it. So you notice here that it doesn't provide full information, I think. If we ask for it directly, let's see what this gets. We'll ask for just that. Oh, it's the same. Okay. So we also can, if we want to just get that, we can say Heroku config, maybe, grep for it. So we don't quite know the name of it, so we can say, show me the config, only the Redis one, and there we go. So we have our variable, right? We have our URL. So now we can go ahead and, in our config file, right, comment that out. We want access to it. So what we're going to say, we're going to say, give us the environment variable, and it's Redis Cloud URL. And maybe we can even ask for, a backup in case, like Redis URL or something, right? In case different providers have different ways of naming things, we can specify backup. So even though this is a YAML file, right, we still get access to the Rails helpers, so we can define our URL that way. Great. So now that we defined it, right, we have our config with Redis Cloud URL. Fantastic. So now we can go ahead and say, great, let's go ahead and see what's new. Git add, git commit. We added the Redis add-on URL. Say git push Heroku lecture 6 master. And it will push for us. Sweet. And we'll clear out our logs, get a fresh start. And cool, it is live. So let's inspect the logs, right? App was crashing, release, build, so it restarts it. Now it's up. And it looks so far to be connecting, transmitting subscriptions. This is all good. This is great. So we'll refresh. And now we go. So now our messages are showing up, right? We've configured action cable. We can do, install Redis, configure it so the action cable knows what Redis to use. But now that it knows that it needs to use Redis, it knows where to look for it, and we use the Redis gem. Our action cable is working. So we can send messages, right? And action cable will use Redis to send that out to everyone, which is pretty sweet. Some more commands just to think about is we actually can say Heroku add-ons docs, and we can ask for Redis Cloud. So it'll open up for us all the documentation. So we can scroll through, and here at getting started, how to create it, how to get the configuration, how to set it up. So if you want access to Redis for other instances, so you want to use Redis for other reasons on your application, it tells you how to set it up so you have access to Redis in your app, so you can start pushing data to Redis and fetching data from Redis. Pretty handy. So that was Heroku add-ons docs. The other thing we can do is add-ons open, and this would take us to the, oops, I spelled add-ons incorrectly. This would take us to the web interface. So this is our dashboard for our Redis. So we can start to see and get information on how the cluster is doing, get some configuration. So here's our database. We have one. We'll check it out, and with any luck, we'll see some metrics. This is just more ways to kind of keep track of your data, right? Once it's out in production on Heroku, it's important that we are monitoring our data and we have a sense of what's going on, so that we can figure things out. Things are going down, bring things back up. It looks like it's loading very slowly. Here we go. We got some metrics, and they're all very baseline. We can look at it on different scales. But yeah, so this is how you kind of open up your interface for that. Great. So we added in Redis. We got Redis working. We run Redis server locally if you want to access Redis locally and use it. So great. Now that we have that, let's take a few minute break, 5 minutes, and then we'll reconvene.